The first rigid motion that I want to talk about is called a reflection. And in order to do a reflection, you need an axis of reflection, and that's this dashed line here. That for this picture, we're going to use that dashed line as our axis of reflection. I need to have a line across the axis of reflection that is a right angle, and the easiest way to do that is to figure out the slope. Well, the slope of the purple line, if you'll notice, it goes up 2 for every 1 that it goes over, so the slope is 2 over 1. Now, if you'll remember from your algebra classes, you'll remember that perpendicular slope to a slope of 2 over 1 is going to be negative 1 over 2. So meaning if we started here, we would go down 1 and we would go over 2 to be right here. So a perpendicular line to the purple line is going to look like that. And so I'm going to use that slope so that I am sure to have a 90-degree angle against my purple line. So to reflect A across my purple line, I need to have it exactly perpendicular to the purple line, the reflection is, and it needs to go the same distance. So if I look at this, A is this far from my purple line. Notice it kind of goes across 4 squares there. If I move this over here, I can see that A prime is going to be right here. And so that's where the reflection of A is A prime. So to reflect B, I have to go perpendicular to the purple line, the axis of reflection. So I'm going to use my other line slope that's down 1 over 2. And I need to go the same distance from the axis of reflection. So we need to move the point that far. So B prime is going to reflect, B is going to reflect to B prime and land right there. Now notice what happens to C. If it reflects across the purple line, it stays the same. It's called a fixed point. So all along your axis of reflection there, you're going to have an infinite number of fixed points. So in order to reflect, you have to have perpendicular line, and it has to be the same distance from the axis of reflection. Okay, on this problem, the first thing we want to do is find the axis of reflection and then reflect the whole shape. So if I first draw a line from P to P prime, I can see that it has a slope of negative 1 because I go down 1 and over 1. So the perpendicular slope, the axis of reflection is going to have a slope of positive 1. So that means we need to go up 1 and over 1, up 1 over 1. So this would be an axis of reflection, that's the slope, but it's not in the right space yet. It has to be halfway between P and P prime. So I have to be right halfway between those 2 points. So a given pair of points is going to completely determine where the axis of reflection is and what the shape looks like after it's all done reflecting. Now notice again on this one I ended up with C being a fixed point, so it's going to stay where it is. Now to reflect B, It has to be perpendicular across the axis of reflection, and it looks like it's 1, 2, 2.5 diagonals across from there. So if I go 2.5 diagonals across, it looks like B prime is going to end up right there. We can see where C is. Let's do A next. Okay, so there's my perpendicular line to my axis of reflection, and A is 1, 2, 3 diagonals across. So it looks like A is going to end up right here. That's where A prime is. So now we can just connect the dots. P to P prime, C to C prime, which was a fixed point, A to B, and B prime to C prime. And there's my trapezoid reflected across my axis of reflection. Now something interesting to notice here, the order going clockwise, A, P, C, B. It goes in order A, P, C, B. But if I go clockwise here starting with A, notice they're not in the same order. It's A prime, B prime, C prime, P prime. So they're not in the same order. So this is an improper rigid motion.